Okay, so today let's talk about inverse functions. So finding inverse functions and being able to show that we know in fact that this is the right inverse function. So I'll give you some little tricks for that. Okay, so let's say for our first example, we have given f of x is equal to 7 minus 2x. Maybe the question says find f inverse of, let's say, -5. Okay, now I'm going to show you two different ways that you can do this. The first way is we are going to actually find f inverse first. And the way you do that, the steps are simply, first thing you do is replace the function notation with y. So you're going to rewrite this as y equals 7 minus 2x. Okay, so we do that. Step number 2, you interchange x and y. And the reason you do this is because if you were going to graph this function, if you were given the graph of a function you wanted its inverse, you simply reflect it over the line y equals x. And when you reflect over the line y equals x, it means the x values become the y's and the y's become the x's. So for example, if in this function f of x, so it's easy to see if I subbed in 2 in here for x, 2 times 2 is 4, 7 minus 4 is 3. So the point 2, 3 belongs to that function. So that means the point 3, 2 belongs to its inverse function because they switch spots. All right, so the next step, you interchange the x and y. So y becomes x, and the x becomes y. Now we do the algebra part, and that is solve for y. Since this is a minus 2y, I'm going to swing it over to the left side. It doesn't make any difference if you do this, but now it's positive. And since we want it to be by itself, it means the x has to go to the other side. It becomes a negative. And whether you write it as 7 minus x or minus x plus 7, same thing. Then solving for y, you get all of this over 2. And then you would say, then replace the y with the inverse function. So f inverse x is 7 minus x all over 2. Then, if you wanted to find, so this is our inverse function. If you now want to find f inverse, so the question said find f inverse of -5. Now you go to your function f inverse. Wherever you see x, replace it with -5. So this will become 7 minus a minus 5, which is 7 plus 5, divided by 2. 7 plus 5 is 12. 12 divided by 2 is 6. Now, if we go back to what I said before, that these points, we know that the point 2, 3 belongs to f of x. That means 3, 2 has to belong to f inverse. Do a little check to make sure. Put the 3 in here. 7 minus 3 is 4. 4 divided by 2 is 2. So 3, 2 does belong to this one. Okay, and if you do that little check right away, especially if you were going to find something else, you want to make sure this is the right function. So find any point that belongs to your original, flip it around, so 3, 2 has to belong to this one, and we found that it did. 7 minus 3 is 4, divided by 2 is 2. Okay, this question didn't ask you to find this, though, first. It said just go and find that. So another thing that you could do, okay, if it simply just says go and find that, okay, using the principle that, notice this is the x value for your function f of x, and this is its y value. If you know what f inverse is, it means this is what x is in the inverse, but it's also what y is in the original. So to solve this a different way, without actually finding the function, this is the y value now of your original function, because it's the x value of the inverse. So you simply go minus 5 is equal to 7 minus 2x. Move the 7 to this side, you get -12 is minus 2x. You get x is equal to 6. So you get exactly the same answer, except you do it simply by substituting it in, all algebraically. Okay, so you're not actually finding the function, because nowhere in the question did I say actually go find f inverse of x. Okay, so if you're given this question as a test question and the teacher doesn't specifically say go find the function f inverse, you can do it this way. Okay, so remember, this is the y value of the original function. Okay, it's the x value of the inverse, but it's the y value of the original. And then you just solve for x, and that is what your f inverse of that value would be. Okay, so there's one example. Let's try another. Okay, so what's really nice with these inverse functions is it's always the same steps over and over again. Your first thing is you go from the function notation to the form y equals. Okay, so in this one, I'm going to give you g of x is equal to 5x plus 1 over 2x minus 3. So this is a rational function. And all I want you to find in this one is g inverse of x. Okay, so what I was saying before is the first thing you do is you replace the function notation with y. So you write it as y equals 5x plus 1 over 2x minus 3. Okay, so regardless of what your function is, that's always the first step. Get rid of the function notation, replace it with y. Next step is always the same. Interchange the x's and the y's. So y becomes x, and the x's become y's. Now, the problem with this one is notice there are two y's. Okay, and all the work is in the step where it says where you're solving for y. So first thing you're going to do is a cross multiply. So that means x is going to multiply with each of these terms. So it becomes 2xy minus 3x is equal to 5y plus 1. Okay, we're still doing solve for y. But notice there are two terms that have y in it. We have a y in this term, and we have a y in this term. What we need to do is bring them to the same side. And it doesn't matter which way you go. I'm going to choose to bring the y this way. That means this minus 3x term has to go to the other side. So I have 2xy minus the 5y, because it's switching sides. Since the minus 3x is going to the other side, it becomes a 3x plus 1. Remember what you're doing, you're solving for y. So both of these terms have a y in it. Don't forget other techniques that you've learned in math. And in this particular case, it's factoring. Factor out that y. You have 2x minus 5, and that's equal to 3x plus 1. Okay, let's move this up here a little bit. Okay, this is just y times a number is equal to this amount. Get rid of that number. Since it's multiplying, you get rid of it by dividing. So you can rewrite this as y equals 3x plus 1 over 2x minus 5. And then finally replace the y with the inverse notation. And there's our new function. There's our inverse function. Now, in this one, to do the little check with the numbers might be a little more difficult because of the numbers that I chose, but I think we can find one here. Okay, if we go back to this function, if I let x, let's say, be 1. Okay, if I let x be 1, that means this is 5 plus 1. This will be 2 minus 3. 5 plus 1 is 6. 2 minus 1 is negative 1. 6 divided by negative 1 is negative 6. That tells me then that minus 6, 1, minus 6, 1 is supposed to belong to this. Well, let's try it. Put minus 6 in here. That's minus 18 plus 1. Okay, so you have minus 18 plus 1 over, put the minus 6 in there. 2 times minus 6 is negative 12. Negative 12 minus 5, negative 17. Negative 18 plus 1 is negative 17. Divided by negative 17, there's our 1. So it tells me, yes, this is, in fact, the right function. Something else that I want you to take note of in this, and it will always work with these rational functions, just focus on the numbers that are here. 5, 1, 2, and 3. So 5, 1, 2, and 3. 5, 1, 2, and 3. Okay, they may switch orders and different ones attach themselves to the x's, but they are the same numbers. And that will always work out to be that way. Okay, I'll do a second part to this in a second, But this is the first part, so a couple of examples of how to find inverse functions.